much better. Okay, thank you very much. So this is Tada from Hitachi, Japan. It is great honor for me to introduce Hitachi solution, which will be able to contribute for making sustainable society. Next slide, please. So this slide shows the contents of today's presentation. Main theme of this presentation is how to reduce power grid loss by advanced applications and useful data platform. I would like to notify the possibility of loss reduction with maintain power grid reliability. Power grid is an important infrastructure so that system operators should balance loss reduction and power grid reliability. Optimization is useful technology to make a good balanced condition. Next price, next price, next slide, please. So to start my presentation, I would like to introduce a rough sketch of the value of power grid loss reduction. I have picked statistical data out from EVN's annual report 2018. Approximately, energy production from power station of EVN is 200,000 million kilowatt hour. Power grid loss rate is about 7% from annual report. It means lost energy at power grid is estimated by 14,000 million kilowatt hour. If we would be able to reduce power loss at power grid by 3%, we can recover 422 million kilowatt hour energy from this simple calculation. Other hand, 5,000 kilowatt wind turbine can produce about 22 million kilowatt hour in case of 50% capacity factor. Finally, we can obtain the value of 3% loss reduction from this calculation. 3% loss reduction is almost equal to 19 wind turbines. Next slide, please. Now, we recognize that value power loss reduction is not so small. However, electric power is very important for secure society. It means should maintain the security of the power system in high-level condition. So we need useful solution to cooperate power grid security and power loss reduction. One of the solution is OpenVQ. So OpenVQ is stand for this slide. OpenVQ can realize online voltage profile optimization. I will explain what voltage profile is in next slide. There are two benefits by OpenVQ. Realize reduction of CO2 emission by loss reduction because loss reduction can decrease the consumption of fossil fuel. Optimal voltage profile also can contribute for enhancing power grid performance. Even detailed feasibility study should be necessary for obtaining the actual value by OpenVQ, but OpenVQ can contribute for shifting power output from conventional generators to renewable energy with smaller capital expenses. Another solution, named HERO, HERO is also stands for this slide. HERO is for realizing effective local consumption of electric energy by rational operation of distributed energy resource, DER. HERO is one of information platform. Optimized local consumption can reduce the burden of trunk power grid effort. Next, please. From next slides, explain what OpenVQ is. First of all, we should clarify the meaning of voltage profile. Voltage profile means coordination of voltage level at all stations in full power grid. This slide shows a simple case. I have calculated optimal voltage profile, which can minimize power loss using mathematical programming. Right column of this table express the rate how much reduce the power loss instead of flat voltage profile. Flat voltage profile means choosing all voltage level maintained by rated value. Usually, there is allowable range of voltage at each station. In this case, voltage is allowed from 19 to 105. When using this range, about 5% loss can be reduced than flat voltage profile. Also, voltage profile strongly depend on the power flow condition. In the near future, we must use the renewable energy. Output of renewable energy is varied hour by hour. Optimal voltage profile should be also adjusted for reflecting condition of renewable energy. That's why importance of advanced online voltage control system must enhance. I believe that OpenVQ is one of the promised technology for this purpose. Next, please. So I would like to introduce the outline of OpenVQ. Our team have confirmed by numerical simulation the benefit of OpenVQ using Tokyo Electric Power Grid data. Especially about 2% loss reduction would be expected, even though TEPCO Power Grid has offline voltage profile determination process. Roughly said, 2% power reduction at the system of Tokyo Electric Power means reduction of about 1 billion yen of operation expenses. Next, please. This slide is how to implement OpenVQ into current system. There are some ways for implementing OpenVQ because OpenVQ can run on the IT platform of Hitachi. IT platform of Hitachi can combine with the current SCADA system of system operator. Output of OpenVQ is very flexible. If the operator has indirect control upon communication for voltage control, OpenVQ will suggest preferable control ways on the display. It means operator will have useful information to send a message to other operator at the substation. Of course, if SCADA system has a function of automatic control of substation devices, output of VQ can be applied directly. Anyway, I suppose operator would be able to obtain the performance of VQ with very small effort. Finally, OpenVQ leverage current power grid asset by setting operating condition to bring out the performance. The demonstration project of OpenVQ funded by NEDO, which is Japanese government, has been started from this December with cooperation of EGAT Thailand. So, next please. Next slide, please. Next slide, please. Sorry. So, then I would like to change the topic. Next topic is introduction of HERO. HERO stands for the Hitachi Energy Resource Optimizer. There is a severe situation to manage DR, such as this figure. Each vendor and the system should communicate and be integrated. Okay. Communicate and be integrated with decentralized energy resources by using its own communication and data protocols. It means there are some silos in operation of low voltage level management. It is necessary more complex function for utilizing DR, such as renewable energy and battery in the near future. Communication of each system must be sophisticated. That's why Hitachi developed the information platform. Next slide, please. If information platform would be utilized, it will be possible to easily realize a variety of high performance management. This technology is important in order to realize the local consumption of energy. In addition, high performance management based on HERO is not only able to reduce the burden of the transmission grid, but also allows to use the DR cooperative control for the performance of transmission grid. Hitachi will contribute, not only provide the HERO, but also develop advanced use cases for distribution grid operators. Next slide. This slide shows an example of system architecture of HERO. HERO is an information platform, so analyticals can be implemented with a simple way. So operator can expand the function of HERO easily. It is very important because maybe we cannot imagine always how to manage DER for the future. We need a trial and error to reach the final goal for sustainable society. So it means heroes concept is concept like hero is very important. Next, this is an example of application on hero. This application provides real-time monitoring, visualization, control to DER, distribution energy resource. The application is equipped with the latest blockchain engine to fit the transaction of each stakeholder strictly. Next slide, please. Another example of HERO is battery management system. Battery management will require not only control technology, but also business evaluation scheme. It means battery management system will be required to calculate when and how much operate battery to minimize effort to maintain the whole grid security. This example depicts one of the use cases on HERO platform. Both examples it means the management and battery management system introduced in this presentation. Hitachi has already demonstrated at the actual. So next, please. So finally, I would like to conclude my presentation. So it is very important to make a smarter operation of power system or power grid, such as the expansion of use of renewable energy and the reduction of losses. Hitachi's two solutions were introduced in this presentation. Transmission system. OpenVQ is for realizing optimal voltage profile to reduce power loss. For distribution side, information platform named HERO was presented. One of Hitachi's most important corporate philosophy is harmonizes with customers. Hitachi would like to offer our solution for realizing sustainable society at Vietnam. Also, it is important to develop excellent human resources and IT solution to support the planning of power grid. Since Hitachi has some solutions in these areas, I would like to very happy to introduce it to you on another occasion. Thank you very much for your attention.